Hi, and welcome to week 5. In this week, we are going to do something slightly different from what we have been doing. Okay, instead of actually looking at circuits and trying to understand how they work, what we want to do is we want to take a step back and think about when these circuits would be required and how we can go about specifying what we want our circuits to do. Okay. Another way of saying it would be what we want to figure out is how these circuits actually fit into a medical instrumentation system. To do that, let's first think about a medical instrumentation system as such. Okay, so I have shown a medical instrumentation system here. Uh, and this system actually measures something from the human body, um, and that measurement is done by a sensor. The output of the sensor is then processed, and this processing could refer to deriving some parameters from the signal. So, for example, if you're measuring ECG, you may want to figure out your heart rate in beats per minute using the signal processing algorithm, right? And the output of the signal processing algorithm is then displayed at the output. Sometimes you can also have the data coming from the sensor stored or the output of the signal processing being stored. Of course, you need a power supply to run the sensor and the signal processing and the output display and all. Uh, Sometimes what we also do is we use this output of the signal processing to control an input to the human body, right? So you can have a control and a feedback block here, which actually controls some input that is going to the human body. Okay, so the central block of the medical instrumentation system is shown here. And one of the things that I think it would be very intuitive would be to see that the output of the sensor needs to kind of be in such a form that the signal processing can actually use it, right? Now, this may not always be true. The output of the sensor may not be in a form that is usable by the signal processing. This is most apparent, for example, if you take a photodiode, let's say. The photodiode has a current output in response to the light input. But maybe the signal processing cannot use the current. So the current needs to be converted into a voltage, right? But there may be other things as well that you want to do. And this kind of processing that you want to do so that the sensor output matches the kind of input that the signal processing requires can be described by a block called the signal conditioning block. Okay, so what is signal conditioning? Signal conditioning is basically converting the sensor output into a form that can be actually used by the signal processing. Now, in most electronic systems, this signal processing and this output that we are talking about are actually in the digital domain. Okay, especially in modern electronics, much of the processing that we do is actually done in the digital domain and not in the analog domain. We'll just get into the definitions of what we mean by digital and analog in the next video. But I think for now, you have an intuitive understanding of what those terms mean. Okay, so if the signal processing and the output display are in the digital domain, then what we need is we need an analog to digital converter in between the signal processing and the signal conditioning circuits, right? Now, what does the analog to digital converter do? It converts an analog signal into a digital signal. Now, what this means, what the placement of the ADC in between the signal conditioning and the signal processing, what does that mean? It means that the purpose of the signal conditioning changes slightly, isn't it? Now, the signal conditioning has to make the output of the sensor has to change the output to a form so that the ADC can operate most efficiently. Okay, so that's where, in one sense, our circuits come into play. So the signal conditioning circuit that we're talking about, So the circuits that we have been learning using op amps and diodes and transistors are going to be used to build these signal conditioning circuits so that the output of the sensor can be transformed uh, so that the ADC can use it most effectively. Hope this makes sense, and we'll get to some more details in the next few videos.